So going on to free air, so you can do them together in this step, or we can do them step by step, which the tutorial does. So we click, excuse me, on free air first. So you can see I've got my master average database. So remember again that this is the master database where we combined everything, and then we took the mean values. So you can see here the mean values of the repeats. So to calculate the free air channel, it recommends using this mean value channel. If you don't believe me, you can go check the tutorial. The elevation channel is here. Output channel is going to be free air, and this is the value used to calculate it. So we click OK. So here's our free air correction, and then gravity Bouguer correction, a bit more detail. So again, the database we're using is the mean or the average 2 database. The free air channel we just calculated. Terrain correction channel. This is, I actually need to go change because remember I typed in terrain correction. Maybe we shouldn't change it, else we might make a mess up here. But anyway, so this is the terrain correction we calculated. This is the free air anomaly channel. And again, like that's a bit complicated because this is actually terrain correction. This is actually the anomaly that you're calculating. Again, remember this density needs to be the same as the density used for the terrain correction window. Elevation, it's going to be output as Bouguer. They recommended applying the Bullard correction. I feel they gave a good explanation why. So here, the Bullard correction changes the geometry for the Bouguer correction from an infinite slab to a spherical cap whose thickness is the elevation of the station and whose radius or arc length from the station is 166.735 kilometers. Somebody else can go learn about the maths of it, but that's it. And when you click on it, you now need to choose a latitude channel, number of Bouguer corrections. So you can now choose a certain range of densities to test, which is cool that you can do that. Now I'm going to get it mixed up, but I think they said for the complete Bouguer anomaly, so now from this we're calculating 2 types of Bouguer anomalies, the simple and the complete, which you can also, I'm sure they gave in. I was just trying to look if they had a nice explanation. Complete Bouguer reduction additionally removes terrain effects by including the terrain correction. Oh, okay. So the simple one, the terrain is approximated by an infinite flat slab, whereas the complete actually takes into account the terrain. But that was why, for the complete terrain correction, they wanted you to use the same density as you used in the terrain correction calculation earlier on. So anyway, for now we're going to use 2 densities, and I don't have water or ice in my area, so I'm not going to worry about this, and I leave that the same, so I click OK. And it now does a correlation for you, from what I understand, between the topography, or the elevation, and the Bouguer correction. We can also just double check that. Correlation. Linear correlation for each earth density. It is between the topography and Bouguer. And so obviously you want a poor correlation. These are very similar here, as you can see. And so please go read through this more. You can use it as a decisive aid. You can actually calculate a subset. Once you find the best density used, they suggest using multiple densities. Again, keep in mind whether you're doing complete or simple Bouguer. And they recommend zooming in on areas where your topography varies a lot, so you can just see that it doesn't correlate with your gravity. Okay, and so I just wanted to plot up here the correction. So I'm just going to use this window. Sorry, let's use a clean window here. So I'm underneath my database, I'm clicking on it, and I'm going to plot here. You can see this is the simple Bouguer, and the C says complete. So I'm going to show it on my profile, and I'm going to show this on my profile. So very similar. I just wanted to check the values are the same. Quite similar. Okay, and I'm going to go on this side and plot up the elevation, which, have I lost now? There's elevation. The reason why there's a color here and it's not showing is because it's showing on one of these other plots. Okay, and so there is kind of an anti-correlation. You can see here the elevation's high and then the gravity is going down. So that is pretty positive. So yeah, that's the end. Calibration, I'm assuming that's for your Lacoste-Romberg. So yeah, then you get your data and then you could plot it up. So let's just check on our channels at the end here. You can see here's our free air channel. These are our two Bouguer channels. And yeah, then you've got your data.